can start it. So how was the exam? Good? Rough? No? Not good? So what is this?
That is our bar chart of our grades.
Histogram.
Histogram, yes.
Yeah,
So
histogram,
that's
that's
what
right. From psychology. Okay. So this is our distribution for the first exam. Okay. So is it symmetric or skewed to the left or skewed to the right?
Skewed to the left.
To the left. Okay. So if I want to describe the center, so should I use median or mean? That's one question, I think.
The mean.
The mean. So someone said, okay, go to the left. So if we want to describe the center, we use mean or median. We use the median, right? When we have the symmetric distribution, we can use the mean. But if it's skewed to the left or to the right, we use the mean. Okay. So that's why I put the median there. Okay. Our median the max, but I'm not putting the mean there because I'm the mean. I didn't work on that, so I'm the leader. So I already included my form of this. Okay. Q1 and Q3. Okay. So this is our performance. Okay. So if you are in this part, okay, don't get discouraged, but please, so if you want to email me to make appointment, we can go through those questions together. Okay? If you want to find out, okay, well, where I did wrong, what can I do to improve, to make improvements in the next midterm and the final, okay? Feel free to email me, okay? And congratulations to people who are on here, okay? And do you have any questions regarding the results? Yes.
The exam was out of 113 points, right?
But that was yes, that is the total point. But from my perspective, I'm using the percentage.
Okay.
Yeah, 90%. This is the percentage. Okay, so 90%, 90% or 95%. Okay. Any other questions? I'm surprised no one is asking for extra credit. So that's about our exam, okay? So if we have no further questions, we will continue our chapter. Okay?
Are you rounding it to a whole number? Like when you fill in the grade book, is it going to be rounded?
You mean this grade or some numbers in the
Just the entire grade. Because like
No.
mine was like something 0.8, so like are you going to round just to the next whole number?
You're talking about the final grade
Yeah,
or
final grade.
final grade? I mean like
Like I got like an 84.8. Is that an 85?
so the final grade I will give A, B, C, D, F, right? So actually that depends on other factors. So if you are here every class or most of the class, if you are say 89.7 something, I would like to
Okay.
I would love to help, right? Any other questions? Okay. Okay. So last week we started to talk about random variables and some properties about random variables. So we discussed two types of random variables. One is discrete random variable. The other is continuous. So in this chapter, we will mainly focus on discrete random variable. Okay? So in the next chapter, we will start to talk about continuous random variable. So discrete random variable, we have a finite number of outcomes for that variable. Okay? And continuous, can take any value. Okay? Maybe for some variables we have the boundaries, but within the boundary you can take any single value. 10.999999 and so on and so forth. Okay? And PMF, probability mass function, PMF. Okay? So that is the function to describe the probability of a specific, the random variable equal to a specific value. And that is for the discrete random variable. Okay? So just like this example. So this capital X is our variable. Okay? And this small x is the specific value. Okay? We use this to describe the probability of a discrete random variable equal to a specific number. Okay? If you want to describe what is the probability of the random variable x is equal to 3, okay? You can use this equation. And if we are interested in the probability that the random variable is less than or equal to a specific value, then we use this CDF, the cumulative distribution function. Okay? So we use the capital F to denote that. Okay? So that's the second function we need to remember. The first one, we describe the probability that the random variable is equal to a specific value. And this one, we describe the probability that the random variable is equal to or less than a specific value. Okay? So two functions. And we also talk about expected value. Okay? So in the business world, we are facing a lot of uncertainties. If we want to make some decisions, for example, we want to invest our money, so what should we do? So last week, Sam said, okay, we use the historical data. That's exactly true. Okay, we use the historical data to calculate the probability for each kind of outcome. Okay, then we use this equation to find our expected value. Okay, so if I want to invest my money in one market, so what profit or what revenue can I expect? Okay. So this is the expected value. So we did this example. Different outcomes and associated probabilities. Okay. And if we use this equation, we can calculate the expected value. Okay. So that's our expectation. And the other thing we talk about is standard deviation or the variance. Okay. We talked about those concepts in the previous chapter. Remember, we have different locations. So sample variance for sample standard deviation, we use small s. Okay. But for the population variance or standard deviation, for population standard deviation, we use a small sigma. Okay. So this is a formula to calculate the standard deviation. Okay. Each possible outcome minus the expected value or the mean to the power of 2 and times the associated probability. And we sum up all those values together. Okay. So that's the formula we use. So how do we do the calculation? We can do it by hand, but it's really time consuming. But here we can use Excel to put the formulas in there. Here I have two options. Okay. I want to invest my money, and here are my two options. So for option 1, I know there are 3 possible outcomes. Okay. So it's likely every day I can make $200. Okay. This is one possible outcome, and the probability of making $200 per day is 30%. Okay. And the second possible outcome, 0. Okay. I do not make money and I do not lose money either. Okay? That probability is 0.4. And the third possible outcome, negative 100, I would lose $100 per day, and the probability is 0.3. Okay? So for this option, I want to see what is my expected profit. Okay? So I can do the calculation to find out what is the expected profit. Okay? Remember, we know the expected value is equal to x times the associated, use the small case. So that's the formula for calculating the expectation, right? So let's use this. Okay. So I can just put in the formula here. Let me. New column, and I can just put in this formula. The outcome times the associated probability times the second outcome times the probability plus the third outcome times the probability. So this is my expected profit. So that means if I decide to go with this option, I can expect to have $30 profit per day. Okay. For option 2, we can do the same. Okay? Let me copy this one. Put it here, and we can use the same formula. Let me directly copy the formula to it. We don't have to type it. Okay? So the product of each outcome and the associated probability, and the sum of them together. Okay? This one times this one plus this one times this one plus times this one times this one. Okay? The same form. And we can see we have the same profit. Okay? So this is the expected value. What about the variance or standard deviation? Let's use the variance. So what was the formula for calculating the variance? If we go back, the variance is equal to the summation of the specific value minus the expected value or the mean square and times the associated probability. So that's how we calculated the variance. So if we go back to the Excel, we can do the same. Okay? Let me copy the one I already did and copy this formula. Which is let me type in. So this value minus the profit, right? A specific value minus the mean and square times the probability. N plus the second outcome minus the same expected value. So the power of 2 and times the probability. And the last possible outcome. This one minus expected value, the power of 2 and times the probability. Okay. So that's a variance. And we can do the same for the second option. Now we can we will see some difference. Okay? We have the same expected value for two options, but the variance are different. Okay? So if you want to make the decision, which option do you want to choose? If you have some money to invest, which option do you prefer? Any opinion?
Is having a higher variance a good thing or a bad thing?
Yes, that's the question. Is a high variance a good thing or a bad thing? So what does variance mean? Is high uncertainty or low uncertainty?
High.
High uncertainty. So if you are a manager or if you want to invest your money, would you like high uncertainty or low uncertainty?
I would like low uncertainty.
Okay. Yeah. So that's why the variance here shows our uncertainty. So if we look at those two options, here we already did our calculation. The expected profit is the same for two options. But for option 2, we have the opportunity to make $400 per day. Okay? That is really a high value compared with the maximum $200 per day. But the problem is, this one is highly uncertain. Although you can have the chance to make $400 per day, but it is also possible that you lose $500 per day. Okay? So that's why, if you have the same expected profit, you may need to consider the variance. So if you would like to take the chance for this option, okay, probably you can make more money, but in the worst case, you may lose more money. Okay? So that depends on your risk preference. Okay? So, but here, that's the number we need to use to analyze our option. Okay? So any questions here? So in the homework, we need to do the expected value and also the variance or standard deviation. Okay? So given the outcomes, the possible outcomes and associated probabilities, we can do that in the Excel. Okay? Then let's talk about some properties. Okay? So regarding the expected value, so still this capital X, so that's our variable, right? And if we plus or minus a constant from our variable, and the expected value is equal to the expected value of that variable plus minus that constant. Okay? So if we know the expected value of X, assuming we know that, and we need to calculate the expected value of X plus 10. Then it's equal to this expected value plus that constant, which is 10. So that's the first property. So how do we know this is true, given this one? So if we can remember that, okay, we can implement that. But if we go one step further, we need to know why this is true. Okay. So this is our original expression for expected value. Okay. The summation of each possible outcome times the associated probability. So if we add one constant to that variable, so this one will be like if x plus C, okay? So this is our constant, is equal to is this correct? I want to calculate the expected value of a random variable plus a constant. So based on this equation or this expression, I have this expression. Is this correct? No? What? Why is not?
You have, the plus C with the X, and,
I don't have, I should have a C here? You mean?
yeah, just by itself,
Okay,
not with the X.
let me give you, let's use that, the profit, 200, 0, and minus 100, okay? The profit, 0.3, 0.4, and 0.3, okay? So if I add a value here, does that change the probability? No, it doesn't change the probability, right? So if I add 10 here, 10 here, 10 here, we still have this probability, right? So if we use this formula, eventually we will get so this is our expected value, right? And the constant times the summation of all the probabilities. And we know that the summation of all the probabilities is equal to 1. Because summation of all the probabilities are equal to 1. Okay? So that's why it's equal to the expected value of x plus this constant. Okay? Again, this is what you need to remember. Okay? So if you are interested, you can do this by yourself, or you want to have a better understanding. But this is not required to know for the exam. Okay? But this is how we prove this is true. Okay. So this is for our expected values. And the next property is for the variance. Okay? Still, we are interested in the random variable plus or minus a constant. And it's still equal to the variance of the random variable. This is one example. If we plus minus any constant, it doesn't change the variance of the of this expression. So I will not do this for the variance, but one thing I want to point out is that if we plus minus a constant in this formula, this we need to add the constant or minus the constant from here, and we also need to minus or add the constant for the mean. So that's why this value will not change. Okay? So that's why the variance is the same, still equal to the variance of the random variable. Okay? So that's the second property. Okay? So standard deviation, we have it's the same as the variance. Okay? So we have this expression. So those are the three cases where we add or minus a constant to the random variable. Okay? Then we know what could be the expected value or the variance or the standard deviation. Okay? And now let's talk about what if we multiply a constant to a random variable. then this would be our expected value. So the expected value of the constant times the random variable is equal to the constant times the expected value of that random variable. You can just take the constants out. We will have this expression. And here is one example. Expected value of 10 times x is equal to 10 times the expected value of x. Any questions so far? So again, you're not required to remember how to derive those things, but you need to know those properties. Okay? The variance. So if we multiply a constant to the random variable, what would be the variance? We have to take the a, the constant out, and use the square. So that's the variance. So that means if you enlarge your random variable, then the variance of that random variable will be squared. So for example here, if you want to double your expected, double your outcome, make this 200, 400, and make this minus 200. You will have more variance. The variance will be squared. Okay. So that's that property. We know the standard deviation is the square root of variance, right? So that's why we have the properties for standard deviation. So remember, this is the absolute value. If 10 is constant, okay, it is a positive number. We can just take the 10 out of that equation. And if we have a negative value, when we take the value out, we have to use the absolute value. Okay? So that's one difference. Okay? Remember, this is the absolute value. So here we are talking about different combinations of a constant and a random variable. So next we will talk about two random variables. So if we have two random variables, x and y, the sum or the difference, we want to calculate the expected value for that. So that is equal to the expected value of one random variable plus minus the expected value of the other random variable. So we are talking about two random variables. So in the previous slide, so we were talking about the small a. Small a represents a constant. But here we are talking about two random variables plus one random variable plus minus the other. Then we can just use this formula. Okay. So if we know the expected value of x is equal to 10 and the expected value of y is equal to 20, and the expected value of x minus y is equal to this guy minus this guy, right? Which is equal to 10 minus 20 equal to minus 10. So the calculation is not difficult. The variance. So what's the variance between the sum or the difference of two random variables? it's always plus. It's always plus. No matter it's plus or minus in here. Here is always plus. Okay? So that's the property we have to be careful. So that's the difference between the expected value. So for the expected value, if here is the plus, we have the plus. If it's minus, we have minus. But for the variance, we always have the plus. Okay? That's one difference. So let me ask you a question. So we have those properties. What if I have those information? We have the standard deviation of x, okay, which is equal to 10, and we have the standard deviation of y, which is equal to 20. I want to calculate the standard deviation of x plus y. Can we use those properties to calculate this one? Is that? Let's think about it. We don't have a direct property for the standard deviation, but based on what we have in this slide, can we do the calculation for this one? We know the standard deviation for x, we know the standard deviation for y. I know I want to calculate the standard deviation of the sum of the two variables, x plus. How do we do the calculation?
Equals the square root.
Okay. 1 second, let me. So equal to the square root of
The variable or the variation.
because this is equal to the is this correct? Okay. Because that's the definition of standard deviation, right? Standard deviation is the square root of the variance. Okay? And if we go one step further, do we have a property for the variance? Yes, we do have a property for the variance. Okay? So this is equal to the variance of x plus the variance of y, right? It's from this property, right? And still we don't have those values, but we know still the definition of the standard deviation. This is equal to standard deviation squared. Let me put it here. So it's equal to standard deviation x squared plus standard deviation of y. So that's how we utilize those two information. And this will be one of your homework questions. So if we are talking about the standard deviation of the sum or the difference of two random variables, we don't have a direct property. We have the property for the variance, but we don't have the property for standard deviation. But we know the relationship between the standard deviation and the variance. So this is equal to the square root of the variance of x plus 1, because this is the definition of the standard deviation, right? And for this one, if we have the variance, we know we have a property there. And we apply that property, we will have this step, okay? Variance of x plus variance of y. Then we apply the definition of standard deviation again. Okay? Because the variance is the standard deviation squared. Then we are here. But from here, we know, okay, we have those two information. Let's plug those numbers in this. gonna be like, 10 square plus 20 square. Okay? I'm not going to do the calculation, but the important thing is how we find the precision. Is that clear? Any questions? So those are the properties of our expected value and variance and standardization. Okay? Again, we have quite a few properties. So if you, it's better to remember those properties, but if you cannot remember, we'll do your homework or your exam. So list those properties on paper so that you know which property you need to use. Okay? Okay, next let's talk about some new concepts. Okay? We'll talk about some specific distribution or probability. Okay? The first one is uniform distribution. Okay? Discrete uniform distribution. So for the uniform distribution, we can have discrete uniform distribution and continuous, but here we just talk about the discrete uniform distribution. So that's the definition for discrete uniform distribution over a set of n values. Each value has the probability of 1 over n. Okay? So that's the equation. Just like rolling a Faraday, we have 6 outcomes, 1, 2, 3, 4, 5, 6. And each value has the probability of 1 over 6. Okay? So that is uniform distribution, discrete uniform distribution. Each outcome has the same probability. Okay? So all the outcomes are equally likely. So that's the discrete uniform distribution. Again, we are talking about discrete random variable. So we can only have finite number of outcomes. Okay? So any questions? Yes?
What's I?
So I here is a possible outcome. For example, if we are rolling a Faraday, I could be 1, 2, 3, 4, 5, 6. Okay? So that's I. Any other questions? So this is the first model we introduced. So before introducing other models, let's introduce a concept, Bernoulli triangle. Okay? So what is a Bernoulli triangle? So there are several conditions. So the first condition is that for each trial, there should be 2 possible outcomes. Okay? We can only have 2 possible outcomes for each trial. Okay? For those 2 outcomes, we define one as success, one as failure. Okay? So this is one condition. So example is if we toss a coin, okay? We only have 2 possible outcomes, head or tail, right? So we can define one outcome as success. The other outcome, we define that as a failure. Okay? 2 possible outcomes. Second condition, the probability of success, so we denote as P, is the same on every trial. Okay? The probability of success does not change over time. So again here, we denote the success as the probability of success as P. And correspondingly, the probability of failure is 1 minus P, right? We only have 2 outcomes. So if the probability of the success is P, then the probability of failure will be 1 minus P. Okay? and the trials are independent. Okay? So tossing a coin, that's a typical Bernoulli trial. Okay? So we have two outcomes, head or tail. Okay? And the probability of success is the same, okay? Half chance. And the trials are independent. So the trials are independent, tossing a coin. Okay? So that's a Bernoulli trial. So any questions on this concept? So another example, if I randomly select a student from our class list, okay, I can define selecting a girl is a success. That's one possible outcome. And selecting a boy is the other outcome. So we have two possible outcomes, right? And each time I randomly select one. So the probability of selecting a girl will not change. Right? So that's the second condition. And the trials are independent because I randomly choose from the list. This is another example of Bernoulli trial. So based on this Bernoulli trial, we can discuss several probability models. The first one is called geometric model. So what does the geometric model do? That's a model for random variable that counts the number of Bernoulli trials until the first success. You try again and again until you see the first success. If you define getting ahead is your success, then you try, and until you see the first ahead. And we define that the P is the probability of success. And the probability of failure is 1 minus P, and we can define as Q. Okay? Q is equal to 1 minus P. Okay? So the probabilities of two possible outcomes. The P is for the probability of success, and Q, which is equal to 1 minus P, is the probability of the failure. And this is how we calculate the probability. Okay? So the X is the number of trials until the first success. Okay? So this is the number of trials we see the first success. So the probability is equal to the probability of failure to the power of the total number of trials minus 1. Okay? So for example, our X is equal to 6. That means when we try 6 times to see our first success. Okay? That means how many failures do we have if we try 6 to see the first success? We see 5 failures, right? And success, the last time, the 6th time, we see a success. So this is X minus 1. So we have, if we have total number of trials X, so X is the total number of trials. And the number of failure is X minus 1. Because this minus 1, this 1 is our success. We only have 1 success. So that's why we have this model. So any questions on this model? here what we need to know is that what's the definition of geometric probability model. So that describes a random variable that counts the number of preliminary trials until you see the first success. Okay? And X here is the total number of trials. So this is one type of model. Okay? So, that's the definition from the textbook. So one thing I want to remind you is that in the StatCrunch, we will show you the calculator later. We have another type of model. So you can define the X as the number of failures. So here we define the X as the number of trials, right? And in some other models, we can define X as the number of failures. Okay? So that's why we can have another type of model, which is this one. So this is q to the power of x minus 1 because x is the total number of trials, including x minus 1 failure and 1 success. And in other models, we can define the x as a number of failures. So in the StatCrunch, they use this model. But in the textbook, they use this model. Okay? So that's why I want to remind you, when you do your homework, we will have example. Okay? So you need to know the x should be the number of failures, not the number of trials. Okay? So let me do one example. Okay? Let me open the StatCrunch. Okay, this question. So a salesperson normally make a sale on 80% of his presentations. So assuming the presentations are independent, find the probability of those conditions. So the first one is the probability he fails to close for the first time on his 6th attempt. So if we look at the question, the probability he fails to close for the first time, okay, the keyword, because we will introduce several models. We need to know based on the description which model should be used. So if you see this kind of keyword, first time, he fails for the first time or he succeeds for the first time. Okay? The first time, you need to know, hey, this is talking about geometric model. Okay? Because geometric model is dealing with the probability that he or she sees the first success. Okay? So here for this one, how do we define the success or failure? You know, this sales person, every trial he only has 2 possible outcomes, right? Success, made a sale, or no. Okay? So that's a probability trial, right? So how do we define? So what is the success? What is the failure here? So what is the success? Make a sale is the success. Okay? So here, what we are interested in the first time he fails to close the deal, right? So we can define the success as he closed the deal. We can do that. But here we are interested in his first time that he does not close the deal. He fails to close the deal. Okay? So that's the event. That's the outcome we are interested in, right? So that's why for this case, we define the success as fail to close the deal. So the success is not the real success. Okay? So that's the outcome you are interested in. So because here we want to see what's the probability that he fails to close the deal for the first time. Okay? So that's why we can define this failure as the success, because we are interested in this event. Okay? So you define the success as the event or outcome you are interested in. Okay? Then failure, correspondingly, that's close the deal. Close the deal. So what is our P? The probability of success. So it says 80% chance he can close the deal. Okay? That means 20% he cannot close the deal. So that's because here we define the success as fail to close the deal. So this P is equal to 0.2. Okay? Yes.
So his failure is our success, and his success is our failure?
Yes. So the so-called success, that's the outcome you are interested in. Okay? Because here we are talking about the first time he fails to close the deal. So you are interested in the outcome he fails to close the deal. So that's why although that's his failure, but that's our success. Okay? Does that make sense?
Mm-hmm. So it's opposite pretty much?
Yeah, so that's something we are interested in. I don't care in reality if he's successful or failure, but we need to define the success as the outcome we are interested in. So that's why the P is 0.2. And the Q, which is equal to 1 minus P, 0.8. So we have the P, we have Q, or 1 minus P. We know which is our success, we know which is our failure. Okay? Then let's do it. Let's do not do this manually calculation. Let's do it in the stack. So let me open the stack function. So under this stat, right? You see the first option, calculator. So under this calculator, we have a bunch of different probability models. Binomial, which we will talk about later. Cauchy, chi-square, and so on and so forth. But here, we need to select this geometric model. Okay. Stat, calculator, and here for this question, geometric. We know this question is asking us to calculate the geometric probability. Okay. So let's click on this. So this is the interface you will get. But here, let me use this standard for now. So first one, you need to input the parameter, the P. Here's your P. Okay? Is 0.2. Okay? And what is the question? The probability he fails to close the deal for the first time on his 6th attempt. On the 6th attempt. So as I said, the stack bunch is using this model. That means this X is the number of failures. So in the description, the probability description, it says he tried six times, and the last last time he failed to close the deal. So last time is the success. So that means we have 5 failures, 1 success. And this X is 5. Because in this model, X means failure. Okay? 5. Okay? So if you have any other calculator which uses this model, the X should be equal to 6. Okay? You have to remember, for in different calculators, they may use different definition for the model. So if the model consider the X as the number of failure, and you know the number of trials, you have to use the number of trials minus 1 as the parameter. But if some calculators are using this model, you don't have to do any calculation. So the number of trials is X. So is it clear? So remember, in this StatCrunch, in this geometric calculator, the parameter X is the number of failures, not the number of trials. Okay? So that's the one thing I need to remember. So this point 0655. Let me put it there. Let me check. Second one. The probability he closes his first presentation on his 5th attempt. Then we have to redefine our success and failure, right? So for the second part, which outcome are we interested in? We close the deal, right? So that's the outcome we are interested in right now. So that's why we define our success as close the deal. Then the failure is the real failure. Again, you see the difference. So our success, our defined success, is the outcome we are interested in. In the first question, we are interested in his failure. But in the second question, we are interested in his success. So that's why we define our success as his success, closing a deal. Then what is the P here? 0.8, right? Now it's 0.8. And Q is 1 minus P, which is 0.2. That we can use the calculator. Still, we have to change the probability. Okay? That's 0.8, and he closed his first presentation on his 5th attempt. So we have 5 trials, which includes 4 failures, right? 4 failures. So that's why our X is 4. And if you can compute, that's our probability. So one reason I want to introduce this example is that we have to define the success and failure for the geometric model. The success doesn't have to be a real success. It could be a failure, like the first question. Okay. But the success is the outcome we are interested in. Okay. So that's the most important thing I want you to take away from this function. So any questions? So you don't have to use those formulas to do the calculation. You can just use this second one. Okay? But first of all, you have to define your success, your failure, and the corresponding probability. And in this interface, the calculator, the between. So that's you find out the probability that his first success happens between one number and the other number. If I put 2 and 6 here, that means we are calculating his first success happens on his second or third, fourth, fifth, or sixth attempt. Okay? So that's when we use this between. Yes.
So for question D, would you use between and put 1, 3?
Let's see question B. The first presentation he closes will be on one of his first 3 attempts. Okay? First 3 attempts, that means could be the first one, second one, or third one. Okay? And what about the fourth one? So how do we explain this one? So if this is asking the first success, so we define success as he closed the deal. Okay? The first presentation he closes will be on one of his first 3 attempts. What would we know from this requirement or the question? So is that possible to have the first time success on the first try? Is that possible? Okay, that's possible. And second one, second attempt. If we have the second attempt as his first success, that means the first one must be a failure. Right? And the third one success, and that means the first 2 are like a failure. So we have 3 possible conditions for this. Does that answer your question? Any other questions? So this is our geometric model. So the requirement is that given a problem description, you need to know, okay, this is talking about geometric probability model. Okay? So the keyword is the first. So if you see the first, okay, you need to think, okay, is this talking about geometric model? Okay? So that's a keyword you need to catch when you decide which model you need to use. Then if you decide, okay, this is talking about geometric model, then let's define the success and failure. Okay? So let's define the outcome we are interested in as the success. Okay? You don't have to care about is really failure or success. Okay? So we define the event we are interested in. Okay? So let's talk about one more model. Then I think we have the time for that. So let's finish this geometric model. Then we will be done. Okay? So some properties for this geometric model. Okay? So expected value and standard deviation. We don't have to be able to derive those properties, but I need you to remember those properties: expected value and standard deviation. So given the parameters, the p and q, which is 1 minus p, you need to directly calculate what's the expected value and what is the standard deviation. So those are the properties for geometric model. only parameter we need is the P. We know the Q is 1 minus P. Okay? So those are the two properties we need to know about geometry. So we will talk about binomial model next class. Okay? So when you get back, because the homework is already available, so you can start working on that project. Okay? So I will see you guys next week.